Thank you very much. I'm honored to be here. And thank you, Margaret, and Heidi and Gwen, and particularly my wife, Dusty. So I have a sort of rapid presentation to give you. I have 5 inventions that I think can help save the world. But first, I want to tell you about my hat. My hat actually is made from this mushroom. And this mushroom is why I think a lot of us are here today. This mushroom allowed for the portability of fire. And you can hollow this mushroom out, pack embers of a fire into it, and carry fire for days. There's no doubt that we all migrated from Africa. And when we came into Europe, we discovered something new called winter. And if our clan could not keep fire alive, our clan would die. I'm going to describe some inventions equally as important in the evolution of humans and life on this planet. And I really need to rock and roll on this magical mushroom mystery tour. So I'm going to take off this hat because it's quite hot. Actually, some ladies in Transylvania have kept the art alive. You boil this mushroom, you pound it, it separates into fiber, and it becomes this. It can be made into garments, hats, purses, coats, etc. So I'll put this down and give it to you, Larry. We are from the Northwest. This is not far from our place. Dusty and I like to go into the old-growth forest on Sundays. This is where we go to church. And in the old-growth forest is a hidden, invisible landscape of mycelium. You can't actually see it, but scientists wondered how could hemlock trees in a dark forest gain enough nutrition to be able to survive. And indeed, it's because of translocation of nutrients from alder trees, quite distant, that would feed these small hemlocks. So the mycelium is a mothering organism that helps habitats survive. And infused in all the roots of most all plants, and through the stems and the leaves are endophytic fungi, saprophytic fungi, mycorrhizal fungi. Most of you are familiar with portobello-like mushrooms. This is actually a species called Agaricus brasiliensis that I co-authored. But most of you may not realize that we are more closely related to fungi than we are to any other kingdom. 600 million years ago, we diverged from fungi. There's a new super kingdom called Opisthokonta. And it was published 2 years ago. A group of 35 eukaryotic microbiologists postulated that indeed we are more closely related to fungi than we are to any other kingdom, and indeed we could be called mushroom people. So the mycelium is this root-like substance. You all have seen it. Just go out into the garden or find any log and tip it over. And what we grow mostly is saprophytic fungi. So we take wood chips, we add mycelium, lots of things happen. But at the end of the day, soil is created. Fungi are the grand molecular disassemblers in nature. And the consequence of their decomposition cycles spurs and supports many other life support systems of many other species. We grow mushroom mycelium on wood. This is actually a spored chainsaw oil. I used to be a logger, and I was amazed at how slowly the clear cuts took to rot. So I invented this and put spores in chainsaw oil that's biodegradable. So when you cut the logs, it would speed up the decomposition process. And we grow lots of mushrooms on straw as well as wood. This is 21 days after inoculation, 23 days, 25 days. Mushrooms move very, very quickly. They're running around you all the time. I'm also fascinated with how mushrooms rot. This is a rushless species, actually in a meadow in the old-growth forest. The mushrooms have great immune systems that prevent bacteria and other organisms from parasitizing them. But after they sporulate, they give themselves up. But the sequence of decomposition steers the subsequent colonies of bacteria and other organisms that benefit the surrounding ecosystem. So the spores germinate around the gills, and very soon this mycelium spreads subterraneanly into the environment. I spent many years as a scanning electron microscopist. I'm going to show you a few of my images. In a single cubic inch of soil, there can be more than 8 miles of these cells. In a single cubic inch. They're incredibly thin. And the mycelium creates microcavities that pulse and fill with water and air. So these are spongy environments. So myceliated soils tend to be soils that are very, very porous, but they hold water. And I inevitably, at the Evergreen State College, my reel-to-reel of several hundred hours of the Grateful Dead, etc., I thought, these look like neurological landscapes. And I was timid to first present this idea for many, many years. And this is the mycelium growing. This is photomicrographs by my friend Nick Reed. And notice what happens here. These are called nodes of crossing. These are nets. This is over 1 hour of time. The mycelium is moving all around you. And the mycelium is multinucleate, so these are packets of nuclei. And as the mycelium streams, it moves back and forth, and it's in constant biomolecular communication with its ecosystem. I first postulated in the 90s that the mycelium is Earth's natural internet. I believe evolution builds upon its prior successes, and the invention of the computer internet is an inevitable consequence of a previously proven evolutionary successful model. I first published this, and I got some criticism for it, but I'm really happy to say at Oxford University and Edinburgh this past year, 2 papers have been published that show that the mathematical algorithms and optima that underscore the creation of mycelium also matches that of computer internet theory. And so I think I've been validated from that point of view. These are photomicrographs by Hank Morgan of brain astrocytes. These are neurons, essentially, and synapses. And I'm going to go way out because this is part of my own personal philosophy. This is the aftermath of a supernova explosion. And mycelium and the internet and matter conforms to string theory. And going way back out now, this is from Scientific American, and the organization of dark matter also conforms to string theory, and these are individual galaxies. 7% of the matter of the universe cannot be observed. It is theorized as being in the form of dark matter. Frankly, this gives me a lot more peace and solitude about my own death, and I think that we'll fall back into this fabric, this great web, this great mycelial archetype. So let's go way back in time. 13.8 billion years ago was the Big Bang. From that spark, the matter was jettisoned throughout the cosmos, and 4.5 billion years ago, the Earth coalesced. Most people don't realize, and scientists did not know until just recently, the first organisms on land were fungi. 1.3 billion years ago, 600 million years later, plants arrived. 250 million years ago, at the border of the Permian and the Triassic period, there was a great cataclysmic event. Most scientists think it was an asteroid. Eruptions of volcanoes also occurred. And when this asteroid impact happened, the Earth became shrouded in dust. Sunlight was choked away from the ground. And because there was no sunlight, huge numbers of species disappeared and became extinct. With all that debris that was created, fungi inherited the Earth. The organisms that paired with fungi survived. We march forward again to 65 million years ago. Bam! Another asteroid impact. And fungi re-inherited the Earth. From these 2 asteroid collisions has steered the evolution of life on this planet. And we are in constant symbiosis with fungi. We now are experiencing 6X, the 6th greatest extinction on this planet that we have thus far have been able to be determined. And with over 50% of the species now estimated to become extinct in the next 100 years, we face a real problem, not only for the survival of the human species, but many other species that we carry with it. There are approximately 1 to 2 million species of fungi in the kingdom. About 150,000 of those are mushroom-forming fungi. About 10% we have thus far identified, 14,000 species. So more than 90% of the species out there we have not even identified. And yet we're losing species, like rivets out of an airplane. How many rivets will you lose before we approach a point of catastrophic failure? And I often wondered if there's a united organization of organisms, otherwise known as uh-oh, and if every organism on the planet had a vote, will we be voted on the planet or off the planet? I think that vote is occurring right now. And we need to look downstream into future generations to see what the implications are of our current activities. So, amazing fossil. This is 420 million years old. It's Prototaxites. It was published just 2 weeks ago in the Journal of Geology by a mycologist by the name of Boyce, a big mystery for many years. It's a large fungus. 420 million years ago, the continents were all together in what's called Pangaea. And they separated. They found these in Quebec and now in Saudi Arabia and throughout the entire world. It was the tallest organism on land 420 million years ago. This is what the land was thought to look at. These were the tallest plants. And these fungi were up to 30 feet tall. Think of that. Fungi had evolved way before humans had evolved. The oldest fungus found so far has been in a piece of amber, not this one. This one's 15 to 20 million years old, but it's a cordyceps mushroom that's found in a piece of amber 100 million years old. 100 million years ago, if you were on this planet and you walked around, you'd see a mushroom, you identify it. But if you saw a little vole-like creature, would you say, that's going to be humans? Hardly so. These are ancestral organisms. They've been around a long time. And because they have developed exquisite strategies, they're extremely clever at adapting to catastrophia. This is the largest organism in the world, is right here, and Dusty and I live right there. This is the Columbia River. We're down here. And I hired an airplane twice, and the pilot and I became friends, so he didn't charge me. I really like that. But, but this is the largest organism in the world. It's a mycelial mat in eastern Oregon, 2,200 acres in size, over 2,000 years old, and it's a single cell wall thick. Think of that. How can the greatest organism on Earth be a single cell wall thick and yet achieve that mass? Because it's in constant communication with this ecosystem, developing exquisite strategies for survival. And I think we can harness upon those strategies. Mycelium munches rocks. It produces calcium oxalate and oxalic acids. And the oxalic acids are joined by 2 carbon dioxide molecules. So it's counterintuitive. We respire carbon dioxide, so does mycelium. But the mycelium creates carbohydrates, but at the same time, it takes calcium out of rocks. And in doing so, pockmarks the rocks, and this is why the fungi came onto land first. It was able to dismantle the rocks and crumble them. But this is the way of sequestering carbon dioxide out of the atmosphere, and my solution to global warming is to invest in humus, using mycelial allies as a way of being able to bring carbon dioxide out of the atmosphere. We live on a thin skin of soil that has given us life, and it's time that we reinvest in the carbon bank of that humus layer. The mycelium then will start producing a mushroom. Mushrooms are so powerful, like Larry mentioned. This is a shaggy mane. They break through asphalt. There's a helical spiral matrix of cells that goes through what's called a dolipror septum, and the spiral forms, and water's pulsing through a one-way gate valve, and it can break concrete, as well as asphalt. These are miniature microscopic explosions that have Herculean forces behind them. We did a number of experiments. I'm going to try to get through 5 inventions in 11 minutes here. This is one that we did in Bellingham, Washington, at the Department of Transportation. There was a diesel spill there for 40 years, and the Department of Ecology was fining the Department of Transportation. They invited scientists to try remediation trials. We went up there. There's 4 piles, 1 test pile, 1 pile was treated with bacteria, 1 with chemical enzymes, and 1 we inoculated with our oyster mushroom mycelium. This is over 200,000 parts per million of PAHs, polycyclic aromatic hydrocarbons, basically diesel, bunker C. The mycelium absorbs the oil. It produces lignin peroxidases and cellulases that break carbon-hydrogen bonds, the same bonds that hold hydrocarbons together. And this mycelium sweats antivirals, antibiotics, enzymes, and these sweat droplets are customized to the habitat to which they are encountering. 4 weeks later, we went back, and our pile was covered with thousands of mushrooms. None of the other piles had any sign of life, and our pile reduced the PAHs from 20,000 parts per million to less than 200 in 8 weeks. The mushrooms sporulated, they start to rot. Then something else happened. The mushrooms became up to 16 inches in diameter. These are what we call happy mushrooms. These are really big mushrooms. Any of you collected oyster mushrooms, they don't normally get this large because they have lots of nutrients to be able to eat the oil. And so then after sporulation, the mushrooms rotted, and they invited bacteria started to grow. But then something else happened. Plant communities came in. Birds came after the larvae, because as the insects laid eggs in the mushrooms, larvae grew, birds came in, brought in plant seeds. Our pile became an oasis of life. And this was an epiphany for me and a pivotal moment in my understanding that these are gateway species. These are primary saprophytes that open up the door leading to habitat restoration. So two of my fungi actually were used by the Department of Defense to break down VX, which Saddam Hussein did use against the Kurds and did kill over 20,000 people. One of my mushroom strains, after a series of experiments, the sole nutrient source was VX, a potent neurotoxin. We were able to train the strains so the only thing that they needed to consume was the potent neurotoxin. This became quickly black boxed by the Department of Defense. This is an ant mound in Washington, and these Lepiota mushrooms are being used by the ants as part of their host defense. And we inoculated some piles of this, and next year we had Lepiota mushrooms all over our yard. And this is a parasol mushroom called Lepiota procera, delicious edible and choice mushroom. And then the next year, we had hundreds of these parasol mushrooms. Insects use fungi as part of their host defense mechanisms to prevent other parasitic organisms. However, Dusty and I lived in what Dr. Andrew Weil called the worst house he's ever seen in North America. He's seen a lot of them. And our house was being decomposed and destroyed by carpenter ants. And so I went on the EPA.gov homepage trying to find a fungus that was not a sick house syndrome fungus and not a fungus that would hurt bees. And the EPA is very excited about a group called Mycelium. These are mold-like fungi, but everybody in the literature and the scientific community said that these little white wedges that don't have spores to avoid them. I thought nature's a lot more clever than that. So I chased these little white wedges in culture. They're called sectors. And I was able to morph the culture into this state, pre-sporulation. And so one night, with my daughter and Dusty, I asked my daughter for a little Barbie doll dish, and I put it down here, right, with all the carpenter ants were consuming constantly the house at night. The little sawdust pile. I'm a good vacuumer. I do a lot of house cleaning. And I vacuum this one spot every day, and so I knew they were coming in there. And so I put down a little Barbie doll dish with 25 kernels of the white mycelium. And then my daughter, at around midnight, had to walk past this dish. And because I inspired the excitement of science, she looked down and she goes, "Oh my gosh, Dad, Dusty, wake up, you gotta see this." And this was swarming with carpenter ants. Now the big thing is over $10 million to $100 million has been spent by DuPont, Dow, all these chemical companies. You're looking for novel biopesticides. But they couldn't get over the spore repellency hurdle. The insects aren't stupid. They know the plague when they smell it. And so they come with these bait stations that they put around people's houses for termites and ants, and the insects would turn around and run away. So they never was able to commercialize. So I did this, and the mycelium is a super attractant to the very insects that would be repelled by this entomopathogenic fungus when it sporulates. So I hit the big home run. And the carpenter ants become mummified, and then, boing, a mushroom comes out of their head. So this is a photograph by Lawrence Gilbert, and I didn't know that these fungi were dimorphic. So the house comes down, and I got my first patent, December 9th, 2003. And then I started making extracts as the choice test, and we make the extracts of the mycelium. The termites and the ants go preferentially to the extract, and I got my second patent in October. This patent is for 200,000 species, all social insects. It's been called an Alexander Graham Bell patent. It could replace all chemical pesticides in the world in the next 20 to 30 years. It also, we can invite in beneficial insects, so it's extremely robust patent invention that I hope can have an enormous impact on saving lives and species on this planet and getting rid of nasty chemical pesticides. So we grow lots of reishi mushrooms. This is a Ganoderma lucidum, my good buddy Andy Weil. And we also grow turkey tails, Trametes versicolor. And we have been approved for the first clinical study in the United States using medicinal mushrooms, a $2.25 million breast cancer study at the University of Michigan, at the University of Minnesota, and at Bastyr College. And one of the mushrooms I'm particularly keen on, and Dusty is too, is this old-growth species called Fomitopsis officinalis, otherwise known as the Garicon, first described by Dioscorides 2,000 years ago. It is a mushroom that's exclusive to the old-growth forest, now thought to be extinct in Europe, even though Dioscorides described it. The trees have been cut down. And its exclusive residence in the old-growth forest in the Northwest is critically important. I've been involved with the BioShield program for the past several years. This mushroom also has an ancient history and has a Venus of Willendorf form, so it's largely associated with women pharmacopoeia. And we started making extracts of these mushrooms, and we submitted over 300 samples to the BioShield program. And lo and behold, we got the results back about 2 years ago. I was under confidentiality and couldn't speak about this publicly until there's a vetted press release by the U.S. Defense Department, which you can Google under Stamets and smallpox. And lo and behold, we hit the big home run against pox viruses, which includes vaccinia, cowpox, as well as smallpox. And there's a selectivity index, and Dr. Earl Kern is a smallpox expert. Any selectivity of 2 or more is considered active. Any 10 or greater is considered very active. We hit 20 and 29. You can Google and listen to an NPR.org interview with me with the BioShield program and John Norris, a former assistant director of the FDA and the founder of the Bioterrorism Institute. Over 200,000 samples were screened. We had the best results and the only active results of any natural product. There's a lot more that has happened now in the past year. I'm sworn by confidentiality not to reveal it, but there's a viral swarm on the horizon. After 1980, none of us have been immunized after that period of time, and the BioShield program sees the smallpox epidemic as being extremely threatening. We have fantastic results against bird flu right now, H5N1, and against SARS. The civet cats kill birds. Civet cats carry SARS. Birds carry bird flu and West Nile virus. Mosquitoes carry those viruses to us. We're all involved in this viral potential pandemic in the making. So I thought more about how can I really save the world? And I came up with this, and I came up with a life box as a way of regreening the planet. And these are footprints that we make through life, and we have a catastrophic effect on nature, and nature rebounds. So I filed a patent on this in actually 2001. We all get too many cardboard boxes, and so or you get DVDs, perhaps of Taste3. And so you get your box, you take out your DVD of Taste3, and then you add water to the cardboard box. A 1% market share of cardboard in this country is 25,000 acres per week. Think of that, 25,000 acres per week. And then I joined 8 vegetables with 1 common friendly fungus. And so it's a uniform mycelial mat sewn into the corrugations of the cardboard. And so once you get the packages delivered, you soak the cardboard for about 5 days, and the spores germinate, as well as the seeds. They're unified. Corns, beans, and squash, and I had onions. My wife thought, if you can grow this, anyone can grow this, because I'm not a gardener. And then so I took several buckets, an old bathtub, an old toilet, and the proverbial kitchen sink. And then 12 weeks later, there's my garden from a life box. And so we harvested onions, and if you use mycorrhizal fungi, you'll get huge onions. You won't get Daryl Hannah and Dusty, but you'll get very, very large onions, because these are fungal allies that enhance the growth of plants and give them host defense against diseases. So we take the corn after harvest, and I developed this for DARPA. I was involved with the Defense Advanced Research Project Agency, and they love this idea. And so then you can take the corn, and now watch this. This is 3 cobs of corn with mycelium. The mycelium's converting cellulose into sugars. And watch what happens right here. Next day, next day, next day, next day, next day. You harvest the mushrooms, and this material is now edible to cows, chickens, and pigs. But then I had another epiphany. For 30 years now, I've been converting cellulose into fungal carbohydrates. And so last September, I had a brainstorm, and I thought, oh my gosh, this is a way of us creating ethanol. And so I trademarked Myconol and Mycohol. And I see the incorporation of fungal knowledge from our ancestors using the lessons of evolution through the theater of evolution. Has been trillions of experiments, most of which have failed, but the ones that have survived and through natural selection have allowed us to move forward. We exist because of symbiosis. When we become unsymbiotic, then we lose the legions of allies and microbes that have helped us get us here. So I believe incorporating these fungal systems into restoration types of strategies all over the world, and that mushroom farms should not be called mushroom farms. They should be reinvented as healing arts centers. We have the power and the wisdom of nature behind us. If we can harness these mycological remedies, I think we can do a lot to help save the planet. Thank you very much.